In this video, we're going to be talking about the veins. Remember that the veins are the blood vessels that bring blood to the heart. The smallest veins, the venules, pick up blood from capillary beds. They then carry that blood into slightly larger veins, and these small veins collect into even larger veins until eventually they return that blood to the atria of the heart. Venules form when capillaries come together at the end of a capillary bed. The smallest venules, the postcapillary venules, look an awful lot like capillaries themselves. Their vessel wall is primarily endothelium with just a few pericytes wrapped around it. Remember, the pericytes are smooth muscle-like cells that wrap around capillaries and the smallest venules. Postcapillary venules are extremely porous, allowing some exchange between the interstitial fluid and the plasma in the venules. Larger venules have a slightly thicker muscular layer in their vessel wall, the tunica media. We're still talking about only 1 or 2 layers of smooth muscle cells, though. Larger venules will also have some of the surrounding connective tissue, the tunica externa. When small venules come together, they form veins. First, venules come together to form smaller veins, and then smaller veins join together to form larger veins. Each small vein collects blood from venules feeding into it, like there, there, and there. And each large vein collects blood from smaller veins feeding into it. The larger veins have all 3 tunics, tunica intima, tunica media, and tunica externa. But, compared to arteries, veins have a thinner tunica media with little elastin, few elastic fibers, and veins tend to have a thicker tunica externa. Veins have large lumens as well, as you can see in these histological images. This large lumen means that blood encounters little resistance passing through the veins, which is a good thing because blood pressure is very low in the veins. The veins are known as capacitance vessels, and they function as a sort of blood reservoir. At any given moment, your veins contain over half of your body's blood supply, up to 65%. Veins also contain valves that prevent the backflow of blood. Since the blood in your veins is under such little pressure, the valves keep that blood from just falling back due to gravity. So, the flow of blood is in that direction, and these valves catch it, keep it from falling back. The venous valves are pocket valves like the semilunar valves of the heart. They allow blood to flow in one direction only. Valves are formed from folds of the tunica intima, so they're covered in endothelial cells. If your venous valves don't work properly, you may develop varicose veins. What happens in varicose veins is that blood pools in the veins in the lower portion of your body. The veins become bloated with blood and visible through the skin. As we've said, venous blood pressure is very low. Much of the pressure, the force from the heart, is dissipated as blood passes through the capillary beds. Since the blood in your veins doesn't feel much of a push from the heart, there are other systems in place that help that blood return to the heart against gravity. When you inhale, the pressure in your abdomen increases and the pressure in your thoracic cavity decreases. This respiratory pump pulls blood back to your thoracic cavity, where your heart is located. You also get assistance from your skeletal muscles. Veins passing through skeletal muscles get squeezed by your muscles as they contract, and this squeezing forces blood through the veins. The muscular pump is the reason why exercise can help keep blood from pooling in your lower legs and feet. The third thing that helps blood return to the heart through the veins is the sympathetic nervous system. The sympathetic nervous system tells smooth muscle cells surrounding your veins to constrict. This constriction helps squeeze blood through the veins. And remember, this whole thing works because the valves keep blood from falling backwards after it's been squeezed. After watching this video and thinking about the veins, you should be able to answer these recap questions. I'll give you a hint on this question here. Think about the blood pressure in arteries versus veins.